Welcome, guys. Hey, look, we're gonna finish up topic 4 here. This is 4-10, and we're gonna learn like linear equations and putting these patterns and equations on the coordinate grid like this. Okay, so I will show you that in just a second. Stay with me. You're gonna learn so much today. I'm gonna help you out. I know it's hard being at home, quarantined and all that. So we will do this together. All right. I taught this today to one of my classes to help um, make sure I'd make this video good for you. Let's read this out loud so we can hear it. Here we go.
Nancy walks 4 blocks to Maria's house. Together they continue to walk. Nancy's and Maria's walk can be described by the equation n equals m plus 4, where n is the number of blocks Nancy walks and m is the number of blocks Maria walks. Describe how the equation, data table, and graph reflect Nancy and Maria's walk.
All right, so Nancy and Maria walks 4, Maria's blocks plus 4 more will equal Nancy. So Nancy walks the furthest. So we're going to describe this on a chart like this. So what you'll need to do is there's the rule. The n equals m plus 4. So m, which is 1, substitute 1 in. So you take 1, you put it up there. And 1 plus 4 is 5. You see how that works? And then 2 plus 4 is 6. 3 plus 4 is 7. Now, you know on the coordinate grid how we have the x and the y? You see the x and the y, and the x comes first. So the number of blocks Maria walks is m. M will be equal to x. I know. Is it confusing yet? So let's look up here. So we go over 1. So this is x, this is y. Over 1, up 5. So let me show you what that looks like, guys. That looks like this, 1, 5. And you would just plot these points. Remember doing this in our last topic? Just plot these points, right, guys? So that's what we're going to plot, and that's what you can see plotted down there. So in your math book, you can look at this too. Over 1, up 5, plot it there. Over 2, up 6. You can see it better in your book. Over 3, up 7. Over 3, up 7. Hey, there we go. So the number, now I want you to notice this makes a straight line, a linear equation. That might be the first time you hear that word, but I'll tell you what, if your parents are sitting with you, they know. Linear equation, you're going to hear that in junior high, in high school, and you're going to be doing so much with taking equations like this. An equation has an equal sign, an expression does not have an equal sign. Taking equations and then graphing them. A lot of junior high and high school stuff there. And you learned it here first. Here we go. I'm going to try to do a good job teaching it to you. So this makes a straight line that goes all the way through. Okay? So let's see what the question is. Describe how the equation, data table, and graph reflect Nancy and Maria's walk. So how does it reflect Nancy and Maria's walk? Think about that now. Okay, let's see what you got. I want you to notice that each of the y coordinates is 4 more than the x coordinates. And you could also notice that each value of n is 4 more than m. You probably saw that. Or you could say is in the equation, the number of blocks Nancy walks n is 4 more than the number of blocks Maria walks m. So you could have said all of that. Let's move on to our next part. There's only 2 parts to this, but once we do this, I'm going to go over to this coordinate grapher and show you some cool things.
How can you analyze the relationship between dependent and independent variables using tables, graphs, and equations? Think about this question during the lesson. The Booster Club members want to raise $50 to donate to a local charity. They buy pom-poms for 55 cents each. How many pom-poms do they need to sell to reach their fundraising goal? To begin solving this problem, which is the most useful quantity to calculate?
Select your answer.
So guys, keep this in mind, okay? The most useful quantity is to find what 1 is. This is known as the unit rate. Unit rate per 1. Unit rate. If you're saying like 5 of them cost this amount, how much does like 9 of them cost? First find the unit rate and then multiply it by the desired quantity. So that's how we're going to do this. You want to find the price per 1.
Begin by calculating the money raised from each sale of a pom-pom. The sale price of a pom-pom is $1, and the cost of a pom-pom is 55 cents. The difference is 45 cents. So, the Booster Club raises 45 cents for each pom-pom that they sell.
So if you're going into business one day, look, they're buying them for 55 cents each. They're selling them for $1. That means they're going to make 45 cents per pom-pom that they sell. This is introduction to running your own business. You want to buy it from a wholesaler for less than you sell it for, and then you sell it and you make a profit. And these profit margins look about right. You usually buy it at about 50% or 60%, and you usually sell it, and this looks about right, what you would sell it for.
Now, let's identify the variables. Let n represent the independent variable, which is the number of pom-poms sold. Let r represent the dependent variable, which is the amount of money raised. How can you use a table, a graph, and an equation to analyze the relationship between independent and dependent variables?
All right, so we're going to set up a t-chart, or a t-chart goes like this, or one going horizontally. They're both the same thing.
First, let's make a table to relate the two variables.
Table, t-chart,
For example,
same thing.
if 10 pom-poms are sold, or n equals 10, then the amount of money raised is 10 times 45 cents, which is $4.50. If n equals 50, then r equals 50 times 45 cents, or $22.50. If n equals 110, then r equals $49.50. Notice that r, the amount of money raised, depends on n, the number of pom-poms sold.
Independent, dependent.
Next, graph the ordered pairs as points on the coordinate plane.
So this might be the part where you get confused. I want you to think of this as x and this as y. So you go over 10, which is probably about here, and then up 450, which is probably about here. Well, this graph is not really. I'm going to show you some easier examples for it. Don't worry.
The points are at the coordinates 10, 4 and 50 hundredths, 50, 22 and 50 hundredths, and 110, 49 and 50 hundredths. Connect the points with a straight line.
All right, so let's look here, guys. This is a little easier example. We'll select a point. The ordered pair here is 8, 4 over 8 up 4. The number of pom-poms sold, n equals 8, so you make a profit of $4 in this case. Let's see. You sell 5 pom-poms, you make a profit of $1. You sell 4 pom-poms, you make a profit of $0. That's called break even. All right, now I'm gonna tell you the equation to this line. So here's what you do to find the equation of the line. You're given this linear equation, and they're saying, "What's the equation of the line?" And you're like, they have no idea what to do. Hopefully you will. Here's what you do. You do have an idea. You're gonna go make a t-chart, x, y, just like that. They call it a table. I call it a t-chart. Now, let's see. You see this one here? Over 8 up 4. So 8, 4. Now, let's just take this one. 6, 2. Over 6 up 2. Let's go to this one now. 4 over 4 up 0, 4, 0. So we're making a chart here. And this is enough to determine what our equation is for the line. Now, do you see a relationship from x to y? What's the relationship from x to y? Do you see it? What are we doing? Is it decreasing? It looks like it's decreasing. Is it decreasing by the same amount each time? If it is, we'll know what to do. 8 minus 4 is 4. 6 minus 4 is 2. 4 minus 4 is 0. Therefore, the equation of this line is x minus 4 equals y. Okay? X minus 4 equals y. You could also write it as y equals x minus 4. That's how typically it is done. And I want you to notice something. This is not a coincidence here, but I'll show you this in more greater depth when you're at school. You see, where does it intercept the y-axis? It intercepts the y-axis at, you guessed it, -4. That's not a coincidence. So if I drew a line like this, what would this line be? Do you know? What would that be? Well, I'll draw another T-chart here. X, Y. When x is 2, y is 0. When x is 3, y is 1. Let me just make sure I'm doing this right because I sketched it. So when x is 0, y is -2. Okay? And when x is 4, look, yeah. When x is 4, y is 2. So when x is 4, y is 2. What's going on here? Do you see a pattern? From 2 to 0, from 0 to -2, from 4 to 2. This line is x minus 2 equals y, or y equals x minus 2. And notice, this is not a coincidence, that it intercepts the y-axis at -2. Very cool. Very cool. Let me show you this over here. So I'm going to bring you up to this coordinate grapher, and I'm going to draw a line right like this. Here, here, here. So I'm freehand drawing this on a computer screen. So it's not going to be exact. You know what I'm saying? That's pretty good. All right, but I did label the points I want to do. So you're given a line like this, and you have to find, your teacher's going to say, what is the linear, what's the equation that represents that line? You'll draw a T-chart like this, x, y. Then you plot the points. This point is 0, 2. 0, 2. You see? 0, 2. X, y. X, y. This one here is 1, 3. 1, 3. This one here is 2, 4. 2, 4. This one over here, right here, is 3, 5. Okay. Do you see a pattern here? Do you see some sort of equation? What's it increasing by from x to y? That's right. It's increasing by 2. X plus 2 equals y. So this line is x plus 2 equals y. Notice that this is positive 2 where it intercepts the y-axis right here. We're making this big blue dot. That's a positive 2. And notice that this is a positive 2 here. That is not a coincidence. You're going to be doing lots of these the rest of your life, okay? At least through high school and junior and college, okay? And junior high. All right, let's get back. Where were we? Here we are. Big lesson today.
Now, we're ready to write an equation that describes the relationship between N, the number of pom-poms sold, and R, the money raised. What number completes the equation shown here? The amount of money raised, R, is 45 hundredths times the number of pom-poms sold, N. To find out how the goal of $50 can be reached, substitute R equals 50 into the equation and solve for N. Divide both sides by 45 hundredths to find that N is a little more than 111. However, the Booster Club cannot sell a fraction of a pom-pom. So, the Booster Club must sell at least 112 pom-poms to raise $50. Now you know how to relate quantities using a table, a graph, and an equation.
See, this is an interesting case because this would normally round to 111, but if we got to say how many pom-poms do we need to break even or whatever, you would need to sell 112 of them. You would go up to the next one. All right. Hope that made sense to you. You'll see a question like that on EnVision. All right. Do this one in your book.
The Booster Club now raises 41 cents for each pom-pom they sell. Complete the table and graph. Write and solve an equation to find how many pom-poms they need to sell to raise $50.
All right. How many do you need to sell to make $50? You guys try this one out now. Okay, so here we go. What you have here is 41 cents per pom-pom. That's the unit rate. So we're going to do 41 cents times the number of pom-poms sold N. All right, so let me get the pen up. Remember, you're allowed to use a calculator. You can see why we're allowed to use a calculator. All right, so 41 cents, 41 hundredths times N. All right, and then I'm just double checking, times N equals R. Equals R. Equals the money raised. Okay, so here, 50 times 41 cents, 0.41 is 41 cents, equals 20.5, $20.50. 100 times 41 cents equals $41. Now 150 times 41 cents, see how 50 plus 100 is 150? Add those two up and you'd have it. But 150 times 41 cents, you can put that in the calculator. 150 times 41 cents is $61.50, okay? Now we're going to graph this. So we go over 50 for, remember this is N, which is equal to X. I know that's confusing. 50 and then up $20.50 about here. Over 100 and up $41. Over 150 and up 61s here. Now, notice how on this this equation right here, do you notice how it's just the coefficient and variable? Whenever it's just a coefficient and variable, it's going to intercept at the origin, okay? This is the origin. Now listen, this is on the quiz, all right? 2 of these on the quiz. When it's I'm going to say it again, it's so important. When there's a coefficient next to a variable without adding or subtracting at the end, it's going to intercept at the coefficient, or it's going to intercept at the 0, 0, the origin. Now let's say, like in our other example, remember it was x plus 2 equals y? Well, that intercepted at 2 on the y-axis. Remember x minus 4 equaled y? Well, that intercepted at negative 4 on the y-axis. But when it goes through the origin, it's just a coefficient and variable. There's 2 examples of that on the quiz. So now we have to figure out for 50 pom-poms, sold. Wait, is that what it says? Let me go back to the question. It says, to raise $50. So we want to know what to do to raise $50. All right, so we're going to substitute 50 in for R. So we have 0.41 41 cents times n equals, and we're going to substitute 50 in there. Now, the inverse, I'm going to change colors because this is so important. The inverse operation of multiplying by 41 cents is dividing by 41 cents. So I'm going to divide by 41 cents here. That cancels out to 1. 1 times n is n. Whatever you do on one side of the equation, you have to do on the other. If I divide by 41 cents on the left side of the equation, I have to divide by 41 cents on the right side of the equation. So now I have 50 divided by 41 cents. Okay? Put that in the calculator. 50 divided by 41 cents. All right, that is 121.9512. At any rate, this is one of those examples where you round it up. It's 122. So you're going to have to sell 122 pom-poms to earn, very important to earn things in life, earn $50. I love it. Can you guys think of a business idea? A business idea like these shields. Someone thought of $1 million idea there by coming up with these shields when the pandemic hit us. Think of a business idea and kind of be an entrepreneur. That's really cool. And you'll have to do all these sorts of graphs to see how many do I need to sell to make this amount of money to live? How much do I need to sell just to break even? Do I have enough revenue to take a loss for this amount of months until I break even and start getting a paycheck? Really fascinating stuff to think about. If what I'm saying intrigues you, maybe talk to your parents about some business ideas or some entrepreneurship, things like that. I know at the high school, I got a lot of former students talking to me about their entrepreneurship class because they know I'm really into that as well. I've started a lot of businesses and I love playing with the stock market and anywhere to use my sixth grade math knowledge to earn money, right? To support yourself and your family. It's really, really kind of exciting. I love entrepreneur mindship. If you are the same and want to talk to me about that, I'd love to hear and encourage you with your ideas. Let's watch this. Oh, it'd help if I hit play.
The temperature was 6 degrees Celsius at 8 a.m. and increased 2 degrees Celsius each hour for 6 hours one spring day. What was the temperature after 6 hours? One way to solve the problem is to make a table to relate the number of hours, n, to the temperature, T. The starting temperature was 6 degrees Celsius. So when n equals 0, T equals 6. Then the temperature increased 2 degrees every hour and 4 degrees after 2 hours. The temperature was 18 degrees Celsius after 6 hours. Notice that the temperature, T, depends on the number of hours passed, n. Another way to represent the problem is to graph ordered pairs on the coordinate plane. Plot the number of hours, n, on the x-axis. Plot temperature in degrees Celsius, T, on the y-axis. Show the starting temperature of 6 degrees Celsius by plotting a point at the coordinates 0, 6. The temperature increased 2 degrees Celsius each hour. As the x-coordinate increases by 1, the y-coordinate increases by 2. Each point on the graph corresponds to one of the rows of the table in step 1. We can extend the line. The dashed blue segments show that the point with coordinates 6, 18 is a point on the line. The temperature was 18 degrees Celsius after 6 hours. Finally, you can represent the problem by writing an equation that describes the relationship between hours, N, and temperature, T. The starting temperature is 6 degrees Celsius, so begin the equation by writing T equals 6. Then the temperature increases 2 degrees every hour, so the equation is T equals 6 plus 2N. Now substitute 6 for N, and then solve for T. Multiply 2 times 6 equals 12, and add 6 plus 12 equals 18. Once more, the temperature was 18 degrees Celsius after 6 hours.
So substituting in is a big one. They'll say like the ninth figure, in which case you would take 9 and substitute it in here, and it would be 2 times 9 plus 6. Or they'll say like, the 8th day, and you would take 8 and substitute it in here, 2 times 8, and then plus 6, following the order of operations always. Let's do this one.
A company makes decorations for pens. All the supplies cost $5, and the company plans to sell the decorations for $2 a piece. Analyze the relationship between the number of decorations sold and the profit by completing the table and the graph. Use the table and the graph to write and solve an equation to find the number of decorations that must be sold for the company to make a $15 profit.
Wow, guys, this relates so much to the real world. This kind of stuff, if you're getting into business and, running your own business or working for a business, this is so much of what you need to know. So this is so valuable. Sometimes we're learning math and it's like about watermelons and apples and things that are just kind of, not really relevant to this kind of profit and running a company and learning how to analyze data. This is going to lead to your success. So pay close attention. Try this one out. I'll pause it. So let's break this one down. All the supplies cost $5. So we're already $5 in the hole. We're $5 in the hole. And the company plans to sell decorations at $2 a pop. That means $2 a piece. Analyze the relationship between the number of decorations sold and the profit. Oh, God, I love this word profit. Man, that means we're making money, okay? Profit. Awesome. By completing the table and the graph. Use the table and graph to write and solve an equation to find the number of decorations that must be sold for the company to make a $15 profit. Amazing. Making money, guys. We're making money. All right, let's do it. So it's $2 a piece. Okay, $2 a piece, but we're subtracting 5. So we have 2, that's the independent variable, each item we sell. $2 times 5, but we got to subtract 5, which is our initial investment. So y equals 2 times 5, or 2 times x minus 5 will give us our profit because $5 is what we invested. All right, so now we substitute everything in here. So take this 3, substitute it in for x, and you have 2 times 3 minus 5. That's 6 minus 5, that's 1. See how I got the 1 there? Now, let's try 4. 2 times 4 is 8, minus 5 is 3, right, guys? Now let's try 5. 2 times 5 is 10, minus 5 is 5. So that means we sell 3 items, we make $1. We sell 4 items, we make $3, is that right? We sell 5 items, we make $5, I think. We want a $15 profit. So let's graph this now. Over 3, up 1, right there. Over 4, up 3. Over 5, up 5. See what I'm doing? That's going to make a straight line. Notice it does not go through the origin. That's the origin, guys. It does not go through the origin, which indicates that it I did not mean to do that. I did not mean to do that. Do you guys remember what this was? Was this one? And then we had 4. We made $3, I think. And then we have 5 and we made 5. Is that right? When it does not go through the origin, that means that you're subtracting or adding at the end of the equation. If it does go through the origin, which is right here, that means it's just a coefficient and variable. That's important. That's on the quiz a lot. 3 up 1. I got my class at Athletes Instinct really soon. I got to finish this. I don't want to rush it, though. This is like 2 full-time jobs doing these lessons at school, and for the people at home, it's like 2 full-time jobs here. All right, so we got, you guys are worth it, though. You're a really good group, really good kids and families. Happy to do it. We got this situation here. So now we want a $15 profit. You see 15? We just go over like that. We go down to see what that would be. So remember our formula, y equals, y is the profit, so we're going to put 15 in, equals 2 times x minus 5. So that's 2 times x minus 5 equals a $15 profit. Let's see. All right, here's how we do this, guys. I'm going to erase this a little bit because I might head that this way. Okay, so here we go. Watch how we do this. Balance this out. 15 equals 2x minus 5. The inverse of adding 5 or subtracting 5. The inverse of subtracting 5 is adding 5. Now that cancels out to 0. Whatever you do on one side, you have to do on the other. So now we get 20 equals 2 times x. 2 times x. The inverse of multiplying by 2 is dividing by 2. A fractions division. Divide by 2. Whatever you do on one side, you have to do on the other. So now we have this cancels out to 1. 2 divided by 2 is 1, and 1 times x is x. We have successfully gotten x by itself. And we do it again on this side, so that means 10 equals x. So we got to sell. To make $15, sell 10 items to earn, I like earning things, $15, okay? Ask your parents if you can earn an allowance or something. It's just really fulfilling to earn money. I'm looking forward to seeing what you accomplish in your life and how you go about doing that. So we did it. Let's go to page 242, and we're going to do 4 through, if you can get up through 12, that's great, but 4 through 9 is good enough. So 4 through 12 if you can, 4 through 9 is acceptable too, because it's tough. I love anything where you have to do the graphing. So I hope you enjoyed this lesson. I'm off to Athletes Instinct to try to get into shape. Bye.